Hello and welcome to another GCSE revision video. In this video we're going to be looking at transformations, specifically reflections. In mathematics, if we create a mirror image of an object, we call it a reflection. Every point in the image is the same perpendicular distance from the line of reflection as the original object. And that's pretty much all there is to it. Okay, well, so much for the theory. Let's have a go at putting this into practice. So we're asked, can you reflect this object about the y-axis? So we're pretending that the y-axis is a mirror, and we want to know what it would look like if the y-axis was a mirror. So we're trying to find the mirror image. So all we have to remember is every point on the object is the same distance or the same perpendicular distance from the y-axis as the image distance will be. So the perpendicular distance will be the horizontal distance, since the y-axis is the vertical line. I suppose I should put y and x just to be sure. Okay, so this vertex here is 3 units up and -4. So it's going to want to be at +4 on the x-axis and remain 3 units up. So that's 4, 3. If I've got the right position. So that's here. Okay, so this point here is at -4, 6, so we'll want +4, 6, so that it's the same distance away from the y-axis. And then this one is at -6, so it's at 6, -6, so this is going to have to be at +6, but still the same value on the y-axis. So that's a 6, and there we have our shape. I haven't drawn it very well, but that's what the mirror image would look like. Okay, let's try another example. Okay, so in this question we're asked, can you reflect this object about the x-axis? So it's the same principle. It's going to be that every point on the object is going to be the same distance away from the x-axis, or the same perpendicular distance. So we're looking at the vertical distance. So if this coordinate is -4, 3, then the image is going to be the same -4, but instead of being +3, it's going to be -3. So I make that point here. And this point here is at -4, 6, so we will want -4, -6. I think that's here. And then this point here is at -6, 6, so I'm going to want this at -6, -6. So I think that's here. So a shape, if I can draw it nice, which I probably can't. Funnily enough, I've never had an art gallery offer to show my artwork. Can't understand why. Okay, so this is what the reflection will look like about the x-axis. Alright, let's try one more example. Okay, last question. Got a pretty gnarly one now. We've got, can you reflect this object about the line y equals 2x plus 1? Okay, well this is going to combine everything we've learned and a bit more. So y equals 2x plus 1, so when x equals 0, y equals 1. So when x equals 0, y equals 1. So I'm going to plot that as a point. Now I need another point. So what about when y equals 0? 0 equals 2x plus 1. So negative 1 equals 2x. So negative 1 over 2 equals x. So negative a half, when x is negative a half, y will be 0. So that's here. So I can now draw the line that joins these 2 points. I need to extend this line perfectly. Let's redraw it from here. Okay, good enough. Okay, so we were trying to reflect around this line. So the perpendicular distance to this line. The easiest way for you to do this would be to get one of your set squares. That's your mathematical instrument that looks like a triangle or a right angled triangle, and you can just line up your line so that you get the perpendicular line. So I would want to get a perpendicular line that goes from these points to this line, and then I would want to extend that the same distance over to the other side. So I'm imagining a perpendicular line that would be I'm going to eyeball it around about here. You would get it much more accurately with your mathematical instruments. So you would use a set square to get your perpendicular, and then you would use a ruler to get the length, and then you'd extend the line. Now for this point, this is negative 4, 3, so again I'd want to draw a line that's perpendicular to this line and extends for about the same length. So I'm going to eyeball it at, oh that's a shame, I think it's going to land exactly on that 4. Okay. And then this point, again I'm afraid I'm eyeballing it because I don't have mathematical equipment that I can use on a screen. it'd be somewhere around here. So our triangle would look something like this. Bear in mind this is only an approximate, you would get a much more accurate one with your equipment. That would be my guess as to what it would, that would be my best guess. But what you would want to make sure is that the distance between here and here is the same as the distance between here. That doesn't look right. That definitely doesn't look right. Let's just check that I've got this right. So this should go to here at right angles, and this should go to here at right angles. That looks about right. It's not exactly right, but then I did eyeball it without proper measurements. Okay, and this. Right, so you want to make sure that these are right angles, and that this is a right angle, that this is a right angle, that this is a right angle, this is a right angle, this is a right angle. So you want to make sure that these are right angles, so these should end up being straight lines, and you want to make sure that this distance is the same as this distance, and you want to make sure that this distance is the same as this distance, and you want to make sure that this distance is the same as this distance. And that's pretty much all there is to it for reflections. I hope you found this video helpful. If you did, don't forget to like, comment if you have any suggestions for other videos you'd like to see me make, and subscribe if you want to see me, or if you want to be notified when I make the video. Don't forget to click notifications on. Okay, if you're taking your GCSEs this year, I'd like to wish you all the best with your revision and all the best with your exams, and I look forward to seeing you in another video.